Hello everyone, welcome to my next tutorial. In the previous video, we have already seen about the design of passive thin film structures properties. Now it is a second part of the video, so we will be discuss about the total internal reflection and Plasmon resonance with consider gold and silver layer, and we will be calculate at here angle dependent reflections, how we can reduce, how we can change their properties. So we will also study at here surface Plasmon resonance sensors about and how we can calculate their properties. In this video we will be seeing. So before start of my tutorial, I want to introduce myself. I am Sahil Verma, application engineer of the well-known company Impulse Technology. So firstly we will be see small presentation about the total internal reflection and Plasmon resonance. So total internal reflection means complete reflection of a ray of light within a medium such as a water or glass from the surrounding surface back into the medium. The phenomena occurs if the angle of incidence is greater than certain limiting angle that known as a critical angles. So we will study about and how we can calculate the total internal reflection in the tutorial we will be seeing. Same Plasmon resonance, it is a phenomena that occur when electron in a thin film metal sheets are excited by light and travel parallel to the sheet. Basically, it is a process when the beam of light is passed through the prism and strike the metal surface like gold and silver layers. It generates electron charge density waves at the interface between the two media that's known plasmons. The metal surface get reflected with reduced intensity. If a thin film inserted between two media, a surface plasmon is excited and the reflectivity is reduced at angle larger than 47 degree. So we will be seeing the examples. It is also basis for the surface Plasmon resonance sensor, a biophysical technique that measure molecular interaction in real time. So how we can calculate these properties in the Setfos we will be seeing. So click at the right side and run as I demonstrate. Who has not seen it my previous video, please check out the playlist. In my first video, I have already explained about the Setfos and their GUI and how we can create new simulation files with different modules and calculate their properties. So for create a new simulation files, click at here. At here we are going to calculate passive optic properties, so we need to activate that tool. We can add more layer with click to the plus I symbol. Now we will be give name one by one. Subtract 1, subtract 2, silver, lithium fluoride. It is a extra layer, so you can remove through the that red single line. It is a delete symbol. The angle for total reflection between high index glass and lithium fluoride refractive constants you can consider at here. It is around 47 degree. That example is considered from the John Lechner given theory of reflection. At Plasmon process, as we know, classical physics phenomena where light excited electron in metal film causing them to oscillate and travel parallel to the thin film. Incident angle you can give at here wavelength 546 nm. Top and bottom layer are semi-infinite medium, so thickness are irrelevant at here, but you can provide at here silver thickness 35 nm and refractive constant and add here 3.28. For subtract, it totally depends on the material which value you want and which value you want to give in this blank space. So layer structure are completed in here and passive optic settings also completed. Now you can give your file name angle dependent reflection and you can simply click at here play button. So you can see at here the optical profiles for the refractive index, absorption, delta, psi, reflectance, stacked contribution, and transmitted. At here optical key figures are given. A surface plasmon resonance sensor is an optical biosensor that measures change in reflective index of a metal thin to detect chemical and biological species. If you click at here the play button, it showing the variation wavelength 380 nm to 780. Its examples are considered from John Laker that give theory of reflection. But if we study about the Frischeisen research paper, they tell about the influence of metal layer on the accuracy of a sensor is studied. In this tutorial, we reproduce p-polarized reflectance for two structures, glass and silver. We can also consider at here glass or gold. So we will be create at here new simulation file for this glass, silver, air. It is a extra layer, so you can delete. You can provide at here thickness value for the glass. At here the new value you can give refractive index of the materials. Top and bottom layer are semi-infinite medium, so thickness are irrelevant at here. So we are considering at here 0, 0. It is a wavelength dependent. We need to import at here refractive index.nk file formats. So we need to import their file. We are calculated at here passive optics settings. You can change at here ranges 450 to 700 and step you can consider at here 2. Wavelength it will be same and incident angle also will be same. But we need to activate the shift settings because we are going to shift incident angle. You can simply click at here incident angle. It will be vary from 41 to 50 and steps considering at here 0.25. It is a simple layer structure example for the Frischeisen who published new research paper. Now you can provide at here your simulation file name Frischeisen first and all the layer structures are completed, so you can simply click at here play button. File already exists, so you can provide at here new name. Now you can click at here play button. So you can see at here optical profiles, refractive index, passive optic properties, solar integrated absorption, and spectral. Frischeisen second consider different layer. It will be gold layer and we need to import at here gold.nk file format. We imports at here au.nk file. It will be same. If you want to change at here shift settings, you can change, and otherwise it can be also same. You can give at here new names. and click at here play button. So you can see at here the variation. Simply you can check at here passive optic properties one by one. Absorption, PSI, reflectance, stat contribution and transmittance. At here both silver and gold have different simulation results. Setfos agree very well with the results from publication of Frischeisen reflectance, measure p-polarization reflectance and for the X-polarization. I hope you got my tutorials and understands about the passive optic properties. In here we discussed total internal reflection and Plasmon resonance. I am going to end that here my tutorials. If you have any query related to this, please ask in comment box, and in the description box email are also given. Who want to book demo, so you can check our website impulsetechnology.in. And in the future video we will be discuss about multi-layer coating, so please wait for the next video. Thank you very much.